Alright, section 9.2 in Trig, graphs of polynomial functions. We want to really understand what's going on with the graphs, different parts of the graphs, maximum values, minimum values, zeros of the functions. Now, these descriptions of things like maximum values, sometimes you might hear them referred to as absolute maximums or minimums as absolute minimums. They are descriptions of the y values, so it has nothing to do with the x values. It has everything to do with what's going on with the y values. These are extreme values, and so the plural of that would be extrema. You'll see that in the textbook, as well as we'll talk about it from time to time. Now, there are other places on a graph which aren't necessarily maximums or minimums, but if you just looked at a small portion of the graph, you probably would consider them to be maximums or minimums, so we call those relative maximums or relative minimums. But that's only associated with a smaller picture within the graph, and I'll show you a couple places, a couple graphs here in a second, especially at the top of page 564 in your book. So let me zoom in a little bit here so you can understand what's going on. In fact, it might be better if I start with graph number 3 first, only because it has some great examples here. So for instance, this graph has no maximum. Clearly I can see the arrows on both ends of this polynomial, this even degree polynomial function, continue to go up forever and ever and ever in both in the top half of the graph, so of course it has no maximum. Now, it does, however, have a lowest y value, and that lowest y value occurs over here at point A. I can see it's the lowest y value on the graph. So that is the minimum. Now, if you were to isolate this little hill and just take a smaller portion of the graph, then you could clearly see that there is a top or highest y value in that little picture. That's what we call a relative maximum. So we've got B, we also have D as a relative maximum. Now, relative minimums, well, in this little isolated place, E. So it's like at the bottom of a valley. C is also a relative minimum. And A is also a relative minimum because it fits the category with the smaller portion of the graph. Now, keep that in mind. Any absolute minimum or maximum is also a relative minimum or maximum. Okay, so keep that in mind. This graph right here has no minimums, no maximums, but it does have one relative minimum and it does have one relative maximum. This graph right here has none of it. There's no maximums, minimums, relative maximums, or relative minimums, because there's none of those little dips, none of those little hills. This one right here has no minimum. It certainly does have a maximum, which also counts as a relative maximum. But there's no relative minimum and no absolute minimum. So those are just some pictures to kind of help you understand what the relative mins and maxes and absolute mins and maxes mean. Now, we want to be able to find zeros. Finding zeros of a polynomial function. So here we have an equation, and I'm going to go into my graphing calculator and I'm going to enter this equation. Negative x to the third plus 5x plus 2. Check my window out. Yeah, I like that window. It's going from negative 5 to to positive 5 in the x direction and negative 15 to positive 15 in the y direction. If you need to get your calculator set, pause the video so you can get it set. I'm going to go ahead and graph this. So if I go to my graph, I went to the table, sorry. If I go to my graph, I see this picture here. Now we can clearly see that there is a relative minimum here. There's a relative maximum there. There are also 3 zeros, 3 places where it crosses the x-axis. We know that zeros are x-intercepts. And we would like to find those places. It looks like one of the obvious choices here is at negative 2. So let's calculate here. We can hit the trace button, and if we want to just guess that negative 2 is one of our values, we can just type it, negative 2. And it did work out to be one of our zeros. But a lot of time we're not going to be able to tell that. Like for instance, this one right here, I don't really know what that one is. Sorry. So I'm going to calculate a 0. It asks me for a left boundary. So I'm going to give it a left boundary. I think that negative 1 is a left boundary. Now I can either type it on the screen, or I can actually use the arrow. But when I hit enter, it's going to put that. So if I want to use the arrow, the right arrow, and kind of climb my way across the x-axis, put that other arrow on there. When it asks for a guess, I'm going to say, nah, I'm just going to hit enter. And it finds out that negative 0.414. Now, I know most of the normal people in the world don't recognize 0.414. Looks like part of radical 2 to me, since that's 1.414. So if I had to guess, I'd probably say that's probably radical 2 minus 2. But you may or may not have recognized that. There are some people who are cooler in the world. So you can try practicing those skills at home. We do need to find this other one over here. So let's see here. That is, it looks like it's between 2 and 3. So I'm going to calculate another 0 between 2 and 3. No, I don't want to guess. It looks like 2.414. Wow. That seems vaguely familiar. Almost like radical 2 plus 1. Hey, don't worry about this right here. I know it says y equals 1 times 10 to the negative 12th. The calculator is doing some calculations, and it's pretty doggone close to 0, so you can assume that it is. It's a very, very small value. It just didn't quite get to 0 as it was doing its calculations back and forth. So, let's see here. We had a picture. Looks something like this. This was negative 2. This was negative 0.41. And this is 2.41. Those were the zeros. Now we're going to split this graph up into pieces. Okay? We're going to talk about a positive interval. Now what I mean by that is, not about the x values, it's about the y values. The x values can be positive or negative. We're finding an x interval that contains only positive y values. For instance, from here all the way to here, from that negative 0.41 to the positive 2.41, all the y values are positive. You can clearly see that because they're above the x-axis. So from negative 0.41 all the way up to 2.41. Now, the only other place on the graph where the y values are also positive would be from -2 all the way to the left on the graph. So how do I describe that? Well, that's from -infinity, which is way out here on the left side of the graph, all the way up to -2. Now, what happens between -2 and -0.414? Well, all those y values are negative. So that interval is -2, -0.41. Now you'll notice that I'm using parentheses and not brackets. Parentheses mean you cannot include the endpoints of the interval, because those endpoints would be zeros. You definitely can't include infinity or -infinity. Now, the negative interval happens from here to here, but it also happens 2.41 to the right. And the only thing out there is infinity, right? So from 2.41 to positive infinity, we're talking about another negative interval where all the y values are negative. So, in other words, we have found the zeros, and we were able to split the graph up into pieces. X intervals where the y values were positive or the y values were negative. So, these are the x intervals. For that particular equation. Now, there's another subject we need to talk about. Increasing, decreasing, relative mins, relative maximums. Try to zoom out here for a minute and then I'll zoom in. So we have this equation. Y equals 1/2 x to the 4th minus 2x cubed plus 3x minus 4. And we've graphed it. And what I've done is I've labeled all of the intercepts, the zeros, but I've also labeled x values for the relative minimums and the relative maximums. Now, we know how to do the positive and negative thing, right? So, for instance, the graph is positive. We got -infinity out here and positive infinity on the right. So from -infinity to a, we're positive. But from a to e, everything's below the x-axis. So we're negative. But after that, from e to infinity, everything's back to positive. So we have split this up based upon x intervals such that our y values fit these terms, positive and negative. Well, now we need to talk about increasing and decreasing. Everything needs to be looked at from left to right, just like you're on a roller coaster, from left to right. So, as you're riding this roller coaster, the y values are decreasing all the way till you reach this relative minimum. And then suddenly you're not decreasing anymore. So, if I were to describe this, I would say everything from -infinity up to b. From -infinity up to b is decreasing. But when I reach that x value of b, the y values start to increase again until I reach c. So from b to c, the roller coaster's going up. But at c, we start to go back down again till we get to d. So from c to d, we're going back down. And after d, from d to infinity. Now I want you to notice something. As I wrote these different, there are no zeros in any of I have not used the zeros in any of these. These are all about relative mins and maxes. This one has no relative mins and maxes. This one's all about the zeros of the function. You notice I used A and E over here. So positive, negative uses the zeros, and relative mins and maxes are used in the increasing and decreasing situation. See you in class.